it's not that eugenics has come back, it's that eugenics never went away. And so the research that I'm doing right now connects this new practice of polygenic embryo screening historically back to the very origins of eugenics. And we can see the same people and the same institutions linking eugenics from 100 years ago, 150 years ago, to today's practice.
Is science fiction becoming science reality? Can we really use embryo screenings to create designer babies, to determine or engineer things like intelligence and other traits? Today on Minds Over Matters, we welcome science historian Dr. Emily Merchant, whose current research explores the modern-day echoes of eugenics. Stay tuned. The way this was pitched to me is designer babies. So take it. Explain it to me like I'm as stupid as I am, please.
Okay, well, Ed, I doubt that you're as stupid as you think you are. But yeah, so and I'll preface this by saying I'm a historian. I'm not a geneticist. I'm working on the history of genetics as it interfaces with the social sciences. And so yeah, designer babies. So something that is currently available if you're doing IVF is that you can calculate for each embryo its expected level of educational attainment. And if you want to, you can select which embryo you're going to implant on the basis of that embryo's expected educational attainment. So how do we know the expected educational attainment? So it's what's called a polygenic score, and it comes from a type of research called a genome-wide association study. So as you probably know, humans are genetically identical at about 99.9% of the loci on our DNA. But so about 0.1% differs from person to person, and a genome-wide association study genotypes many, many people at all of those loci where people are known to differ from one another. And then for any outcome of interest, so it could be educational attainment, it could be a disease state, a genome-wide association study will examine at each loci, does having a different nucleotide at this spot make a difference to whether a person gets a disease or not, or has more or less educational attainment, or you can do it for any outcome there is. People have even done genome-wide association studies on the likelihood of participating in a genome-wide association study. So which genes make you, I shouldn't say that, which genes correlate with being more likely to participate in a genome-wide association study, or which genes correlate with having more educational attainment. So what a genome-wide association study finds are correlations. We don't know if there's any causal relationship, but they can figure out which genomic variants correlate with one outcome as opposed to another. And you can calculate a correlation for any two variables, whether they are actually related in real life or not. And that correlation will almost always be something other than zero. It'll be positive or negative. It's very rarely actually zero. And so this is why statisticians have come up with measures of statistical significance. So we can say, okay, but does this correlation actually generalize outside of this population? And in a genome-wide association study, the scientists are not actually interested in statistical significance. They're just interested in the magnitude of the correlation. And so once you know the magnitude of the correlation across all of the genomic loci that differ from person to person, you can then genotype any person and calculate their polygenic score for whatever outcome you're curious about, whatever outcome the genome-wide association study has been done on. And for most outcomes, the correlations with any particular genomic locus are minuscule. So we're talking about, maybe one extra day of education if you have this nucleotide as opposed to that nucleotide. And to even calculate those, you need enormous sample sizes. And this is why people in the field of sociogenomics, so that's this interface between genomics and the social sciences, people in that field have focused on educational attainment as their outcome, their main outcome of interest. And this is because there's just so much data. So the most recent genome-wide association study of educational attainment had a sample size of 3 million people. And you just can't get those kinds of sample sizes for any other socioeconomic outcome or any other kind of social outcome. And so this field of study has really focused on educational attainment just because the data are available, but also because educational attainment is kind of the key to every other positive social outcome that there is. And also because people in the field tend to see it as a proxy for intelligence. And so that's why prospective parents might want to select embryos on the basis of expected educational attainment to produce more intelligent babies.
See, the way you said that, now I understand it. Thank you for that. I get it now. I have to point, it sounds like this is read-only, correct? I mean, we cannot engineer, you can't tweak those strands of DNA to reflect. Like, I want to have a kid with a really gigantic brain who's plays first chair for the London Philharmonic and comes up with a cure for cancer.
Right. So in theory, you could. In theory, we know the correlation between every locus on the genome and a person's educational attainment. So in theory, you could use CRISPR or some other gene editing technology to tweak those in an embryo. However, nobody is doing that. This is because we still, as a society, have not agreed upon whether it's okay to edit the edit the genomes of embryos. There are now startups that are doing research on this with the hope of making gene editing of embryos commercially viable, but it's not yet available. But the other reason why you might not want to do it for educational attainment as opposed to some other genetic outcome is because educational attainment is correlated with so many variants across the genome. And as I said, any one of these variants makes the tiniest difference. So you would have to edit just about, every one of these 0.1% of the variants or of the loci on the genome that vary from person to person. So it would be a lot of editing with a lot of potential for something to go wrong or for unintended consequences. So nobody is actually talking about doing this. Right now, polygenic scores are only used to select embryos, not to edit them. And I should say, it doesn't actually work. There was a study in the New England Journal of Medicine in 2021 that found that an embryo selected from an IVF batch to have the highest educational attainment of a given batch of embryos would not have a statistically significant difference from an embryo chosen at random with the same parents. So this is a thing that people can do. It has science behind it, but the science actually suggests that it wouldn't work in the way that consumers of this service think that it would.
But being the capitalists that we are, it's not stopping people from trying to make a buck at it, right? There's a market out there for this, correct?
There is absolutely a market out there for this. Yeah.
And they're targeting sounds kind of nefarious, but I guess in the end of the day, it kind of is nefarious. If it's like the Emperor's New Science and there's no real deliverable, it's just the promise of a thing, maybe. But they're targeting like tech CEOs, right?
Yes.
People who are 99% ego, I should say, with some overachiever pinched in there, I guess.
Yeah, so it's a very expensive service. We're, talking about thousands of dollars on top of the cost that you're already paying for IVF. And yes, and it's kind of speculative science. It's not very well established yet. And so the companies that offer it are targeting people in the tech field, people who are very tech-oriented, and the people who are interested in this tend to have an affinity for the ideology of transhumanism, which is the idea that we can exceed the bounds of human existence, improve upon existing humanity through technology, so through gene gene editing technologies, through polygenic embryo selection, through things like neural implants. So those are the types of people who this is appealing to.
And I don't imagine it's lost on anybody who is familiar with this at all. That I think there was an article recently called "Echoes of Eugenics," which this kind of carries that notion forward. Or it revisits this. As a matter of fact, I have to say, an aside, I knew that we were going to have this conversation today. I woke up this morning and I did my usual routine, coffee and Instagram. First headline I hit was "Eugenics is alive and well," and it was referencing the Nazis and some correlation between people who were not lactose intolerant and a superior race, or is like I struggle to make sense of it. I want to chalk half of that up to the fact that the coffee wasn't fully ingested, and then the rest is probably just to my natural, like, oh, you lost me. It's too long, didn't read. And plus it's Nazis. How much do I really want to know? But the fact that eugenics is being talked about now in these days, and this science is alive and well, and kind of hints at connections. But
so yes, eugenics is alive and well. Polygenic embryo selection for educational attainment or intelligence, the two often get conflated, is absolutely a new form of eugenics. And it really has the same aims as older versions of eugenics. Eugenics, from its beginning, the idea was to control human reproduction in order to increase intelligence at the population level. And so it's a new method to achieve the same ends. And even some proponents of polygenic embryo screening for educational attainment, even some proponents of this describe it as eugenics, but in a positive way as opposed to more of a negative way, which is how I feel about eugenics. And this also, it's not that eugenics has come back, it's that eugenics never went away. And so the research that I'm doing right now connects this new practice of polygenic embryo screening historically back to the very origins of eugenics. And we can see the same people and the same institutions linking eugenics from 100 years ago, 150 years ago, to today's practice of polygenic embryo screening through the science. And the science is what connects the older version of eugenics to today's eugenic practices. Yeah.
And I the context that I heard about it this morning was racist, creating a master race, being able to determine through this technology, or the technology that's available now, the color and the which you talked about the limited sample size before. We should talk about that a little bit, because a lot of what's available out there came through like 23andMe and things like that. But it is an admittedly small fraction of humanity that for which we have that kind of data. Is there anything that suggests that small sample is not going to be accurate outside of this window, like this? This, if you are between the ages of and you are this ethnic background and such.
Yeah, absolutely. So I think there's a lot of eugenics frequently gets confused or conflated with race science, and the two are definitely related, but also distinct. So the word eugenics was coined by Francis Galton in 1883. Galton was a British kind of dilettante gentleman scientist, but he was a cousin of Charles Darwin. And Galton lived in a world in which scientific racism was normal. It was everywhere. There was a common belief among people of his social status that groups that have been racialized differently actually represented different subspecies of the human population. So this idea that people on different continents represented kind of genetically distinct groups. They didn't have the word genetics then. They used the term germplasm to refer to what we would now call DNA. But there was this idea of distinct groups, which we now know is not true. But what Galton added to that with the concept of eugenics is this Darwinian notion of variation within species. So what Galton recognized is that even among white people in England at the time, that there is genetic variation among people of a given racial category. And Galton attributed socioeconomic inequality to that genetic variation. And so his idea was that the white race could be improved by selectively breeding the more intelligent, the more socioeconomically successful members of this white population, and that would advance global white supremacy. So that's how it connects back to racism. And it is the same project that we're seeing in polygenic embryo screening. And the reason for that is because the research underpinning polygenic embryo screening has only been done on white people. And the reason for that is because this idea that different racial categories, differently racialized groups represent genetically different segments of the human population, that incorrect idea has persisted in many pockets of science. And so typically when genome-wide association studies are done, not just in the social sciences, but across the board, they are done on people from a single racial group, which gets discussed in terms of continental ancestry. So they talk about European ancestry populations, African ancestry populations. But these population categories map exactly onto our racial categories, and in many ways mean the same thing and are equally biologically meaningless. But because of that, all of the genome-wide association studies on educational attainment have only been done among white people. And because white people and people of color experience very different have very different experiences of the educational system. As we know, white people have a lot of privilege going through the educational system in white majority countries, which is where all the data come from. We're not going to expect to see the same genomic variants even correlating with educational attainment in people of color, not because the genome is necessarily different, but because the environment is different, right? Even if it's the same environment, it's different in practice because people are experiencing it in different ways. So the polygenic scores, to the extent that they are even predictive of educational difference among white people, they are not at all predictive of educational difference among people of color. So this type of polygenic embryo screening would not work on people of color. It doesn't work very well on white people either, as I've said, but there's even less of an expectation that it could work on people of color. And then, as you said about the limitations of the sample, even among white people, the samples are not representative of all white people. So genome-wide association studies really are done with samples of convenience. You need as much data as you can get. And so the people who do genome-wide association studies will combine data that was collected by different people at different times for different purposes. And so you mentioned 23andMe. That's actually the source of most of the data for the most recent genome-wide association study of educational attainment. So it was a sample of 3 million people. I believe about 2 million of those people came from the 23andMe database. And so we know that these are people who have paid for a commercial service, so it's not a representative sample of anyone except 23andMe customers. A lot of data for that project also came from the UK Biobank, which was a project of the UK government, and it was originally intended to be representative of the UK population, but it had such a low response rate that it ended up not being representative at all. And this is why you can do a genome-wide association study on the likelihood of participating in genome-wide association studies, is because the people who are included in these studies are systematically different from people who are not included in these studies. So we really don't know who these results might generalize to.
There's so many strange twists and eddies and conflicts. One of the big contradictions I'm seeing in this is that once upon a time, a race dreamed of having everyone like itself, and they put their money into this science, which at the end of the day could only assist in identifying embryos that would grow smart enough to prove them wrong. Talk about ensuring, like that's just, the mind boggles, like that's just the snake eating its tail. It's meant to be, I suppose. It's such a strange thing. So I want to go back to another thought that I had. This isn't a behavior or a trait predictor, is it? I mean, can you use this technology to define traits? And what the allegory I would use is like, they breed dogs based on their ability to hunt or to track or to herd cattle or something like that, or sheep. I'm not sure. Can you engineer for those traits?
So in theory, you can engineer for any trait. You can do a genome-wide association study on any trait and then use the results of that study to calculate polygenic scores that you then use to select embryos. So yes, so in theory, that is totally possible. Any trait that can be kind of quantified, you can do a genome-wide association study and you can use the results to select embryos. And I'm going to go in two directions on this. So one is the speed with which that selection would work. Polygenic scores are actually not very predictive of the outcomes that they are intended to predict. They actually explain a very small amount of the variance in those outcomes. And I'm talking about educational attainment, but I'm also talking about diseases. Even in the medical field, polygenic scores, they're also known as polygenic risk scores, actually account for a very small amount of the risk of being diagnosed with a particular disease. So they're not very predictive, and so we would not expect that polygenic embryo selection would actually change the population very quickly. We would expect a very small, if it worked at all, we would expect a very small change from generation to generation. So there's some speculative technologies that are being researched at the moment, again, mainly by startups who want to be able to market this, to speed up the rate of selection. So one of these speculative technologies is in vitro gametogenesis. And so this is the idea of being able to take cells from any part of a person's body and turn them into sperm or egg cells. And if you can do that, then from 2 given people, you can make hundreds of embryos, right? In a typical IVF cycle, you might get 10 embryos, but with in vitro gametogenesis, you could make hundreds of embryos. And with more embryos, there's more of a chance that one of those embryos would be on the very high end of the polygenic score for whatever trait you're trying to engineer.
And just to interject for a second, the harvesting doesn't rely upon different genders or different sexes, right? You could have same-sex couples who reproduce this way.
Right, exactly. And that's, one of the ways in which in vitro gametogenesis will be marketed. So it's not commercially available yet, but when it is, I think it will particularly be marketed to same-sex couples because you can have a child then who is biologically related to both parents, which is a really cool idea. But then there's also these other things that you can do with in vitro gametogenesis.
I love the poetry of it being such a huge slap in the face to the usual to Nazis. We wanted a white race, and now we've got everything opposite.
Yeah, and so that's one of these speculative technologies. Another one is the idea that you could start with 2 couples and for each couple, make a set of embryos, choose the embryo with the highest polygenic score for whatever trait you're trying to engineer from each couple, and then take cells from those embryos, turn them into egg and sperm cells, put them together, and make new embryos, which would be expected to have an even higher range of polygenic scores for whatever trait you're trying to engineer, because you've taken from the first batch of embryos those with the highest polygenic score. So you've now done 2 generations of selection at once. So you're basically doubling, probably more than doubling, it's probably an exponential effect, the rate of population change as a result of polygenic embryo selection. And again, this already requires in vitro gametogenesis. So these are both very speculative, not available yet, but people are researching them for this specific purpose, for the purpose of speeding up population change through polygenic embryo screening. So that's one direction I wanted to take it. The other direction is back to dogs. So you mentioned about dog breeding, and yes, so the wolf has become many different breeds of domesticated dogs through hundreds, maybe probably thousands of years of selective breeding. In the 1950s. So this is after World War II. This is after maybe we should have known better about eugenics. The Rockefeller Foundation funded a project at the Jackson Memorial Lab in Bar Harbor, Maine, a project carried out by 2 psychologists who were tasked with breeding a particularly smart dog. And the idea was that this dog could be turned into a commercial product. It could be sold as pets for people who wanted very smart pets, but also that it would be kind of proof of concept for eugenics. And so it would help the American public embrace eugenics because with the idea that if we can breed smart dogs, we can also breed smart people. And the psychologists who were working on this project, this was John Fuller and John Paul Scott, and they published a book about this in 1965, were ultimately unable to accomplish this goal. What they found was that dog intelligence was just so multifactorial that they couldn't even satisfactorily measure it. And without a measure, you can't optimize it. So they couldn't even satisfactorily measure it, much less breed for canine intelligence. And
yet those traits seem fairly consistent within a breed, like Border Collies, traditionally known as being among the smarter dogs. Belgian Malinois, don't even. Are you familiar?
I'm not. No,
Okay.
I don't know much about dogs.
Think about a German Shepherd if you fed it a steady diet of crack and heroin. That's what a Belgian Malinois is. Adorable, lovable, but oh my goodness, do not get in its way. But so these traits are there. And so I'm going to back up a little bit. What I'm hearing you say is, scientifically, it's possible. Technologically, it's possible to engineer the society you want, or be where you think you want. That leads me to the second part of this. It's not there. We're not there yet. But if we had a large enough data set and we could use CRISPR in new and creative ways based on information, we could increase the odds of producing a society according to a blueprint, or something like that. The question is, if we could, should we? There's a huge ethics debate around this, is there not?
Yeah, so I'm actually going to push back on the premise of the question, and this is one of the things that I try to do in my research, is to say that the ethics debate is a little bit misguided, because the ethical debate assumes, as you said, that it's possible, that it's scientifically and technologically possible to engineer human intelligence or any other kind of traits that we want at the individual and at the population level. The science, I would say the science is still very iffy about that. So, I mentioned a 2021 study in the New England Journal of Medicine that found no statistically significant difference between an embryo selected for educational attainment and an embryo selected at random in that trait of educational attainment. And the reason for this is kind of what I went back to before, is that polygenic scores are actually not very predictive. They only even, in air quotes, work among white people. And even then, they don't predict much of the variance in any trait. So educational attainment, disease, anything. And so then there's debate about why. Why haven't we been able to find genes with a very strong correlation with intelligence, right? So any of these genomic variants accounts for only a few days or maybe a few weeks of educational attainment. We don't have any variants that account for a substantial portion of difference in educational attainment. So why is that? And so proponents of polygenic embryo screening say, well, they must be rare genes. So we haven't found common genes or common variants. We haven't found common variants that account for much of the variation in educational attainment. So there must be rare variants that we haven't found yet that account for the bulk of that variation. There's no real evidence for this. We haven't found any rare variants that correlate with a substantial proportion of variance in educational attainment. But the reason why people expect that we will is because of an older concept called heritability. And this is actually the concept that pretty directly links the eugenics of the past with the polygenic embryo selection of today. Heritability is a measure of what percentage of the variance in a trait is due to genetic variation as opposed to environmental variation. This idea came directly out of both eugenics and animal breeding in the interwar period, so the 20s, 30s, and 40s. And it's used today to justify efforts to continue looking for rare variants that correlate with educational attainment, even though, we haven't really had any luck with the common variants. So heritability in humans can only be measured in twins. And this is because you can't do breeding experiments on humans. You can only use kind of natural experiments. So the idea behind this natural experiment through which you measure heritability is that identical twins share their entire genome and their environment, whereas fraternal twins share their environment, but only half of their genome. So if you look at the difference between similarity of identical twins and similarity of fraternal twins, you can use that difference to calculate the percentage of variation in a trait that is that can be attributed to genetic variation. There are many, many reasons to believe that heritability figure overestimates heritability. Beyond that, heritability is often talked about as a property of a trait. So people will say educational attainment is 40% heritable. That's the figure that comes from twin studies. But heritability is actually a characteristic of a population. You would have to say, educational attainment is X percent heritable among a given population, among twins born in the United States in the 1960s or whatever. And it's not clear at all that heritability can be generalized outside of the population in which it's measured, or even from twins to non-twins. So there's many reasons to think that these heritability estimates have been kind of overestimated, that these heritability estimates are too high. But these high heritability estimates have served to keep open the search for intelligence genes. So at the moment, the most recent genome-wide association study has found 16% of the variance in educational attainment among white people in wealthy countries. Unrelated white people in wealthy countries. So the idea is that, okay, we're missing, and this is the phrase they use, missing heritability. We're missing 24% of the heritability, right? Because we're expecting to get, from the twin studies, we're expecting 40%. The genome-wide association study has given us 16%. So there's 24% missing. And so that keeps open this search for rare variants that might account for that 24%. And so, even when people, point out that we haven't accounted for much of the genetic variance in educational attainment, or, this 2021 study that showed no statistically significant difference, proponents of polygenic embryo screening will say, well, that's what we've found so far. But we know that educational, and I should say no in air quotes, that educational attainment is 40% heritable. So eventually we will be able to find that other, the genes that account for that other 24%, and polygenic embryo screening for educational attainment or any other trait will become much more effective. So what I'm pushing back on is that claim that we can actually do this kind of genetic engineering of people. I think we need to take a step back and really question this science and say, does it actually work the way that its proponents claim?
And what are you hearing as far as I could hear the bullet points flying from both camps, like pro and anti. Give me an idea of what some of the anti people are saying about why we shouldn't do this. Is it largely religious based? It's like a poke in the eye of God or something like that, or is there like a lack of safety, concern for the safety? Like we might be breeding another generation of aliens or something like that, or the pluribus takeover kids or something like that. So what do you hear as far as that goes?
Yeah, so I will say there's all kinds of reasons on both sides for why we should or why we should not pursue polygenic embryo screening for educational attainment or any other kind of socioeconomic metric. My argument against it is that it diverts resources that could be used to create better environments for everyone, resources that could be spent on improving public education, for example. It diverts those into these biotech companies that are doing this polygenic embryo screening. And it encourages parents to invest in the genome of their own child rather than the education of society as a whole. So I think it's an inefficient use of public and private resources. But also, given that it doesn't work, promoting this kind of polygenic embryo selection also produces belief in the idea that our intelligence or our educational attainment is genetically determined in ways that science really hasn't shown it to be. So I think it also creates general misconceptions about the nature of educational attainment or the nature of intelligence or the factors that go into educational attainment. So those are kind of my arguments. Other arguments, that it's a matter of playing God, or that that anytime parents try to design their children, they're not accepting the children for who they are. The idea that we could end up with a genetically stratified society. So if this polygenic embryo selection is only available to people who pay for it, if it does work, it could create a wide genetic gap between the people who use it and the people who don't use it. Even proponents of polygenic embryo screening have cautioned that it could create more genetic homogeneity among, especially if it were made available to everyone, for example, could create more genetic homogeneity, which could make the human population less resilient to disease and other kinds of threats. So there's a variety of reasons why people would be against it. The reasons for it that people cite, and again, these depend on it actually working, are that, with more intelligent humans, we can solve more of humanity's problems. So these are also the arguments that are made in favor of promoting artificial general intelligence. And there's a strong connection. So Sam Altman, for example, the CEO of OpenAI, is heavily investing in companies that are doing all of these genetic technologies. So from polygenic embryo screening to embryo editing, as far as I know. So there is a connection there, the idea that having more human intelligence can help us create artificial general intelligence, and that this increased intelligence of the human and artificial variety can help us solve big problems like climate change, for example. And then, a more kind of, at the human level, people argue that parents are obligated to give their kids the best start in life that is possible, right? And so if you can give your kid, again, air quotes, better genetics, that's an ethical obligation of parents. So those are the arguments on the pro side.
And I can't help but note the irony built into that whole thing is that the natural process of reproduction and evolution and growth is responsible for giving us the technology that we are, it's like evolution seems to be doing fine by us. Would I like to see it speed up? Absolutely. But I'd like to actually see it maybe address some management issues as far as, what voice we allow. There, you're familiar with the paradox of tolerance. There are things built into us sociologically that I think we need to really, step back and look at that are not so much breeding a smarter human being as saying, let's convince everyone of what the right path is, because the intelligence is here. Look at what we've been able to do. We've been able to identify these. We've decoded the human genome, which is not a small thing. And that happened in Santa Cruz, right? UC Santa Cruz? I'm not going to hold you to that. Trust me. I'm pretty sure that's their claim to fame. Go slugs or whatever you are. But yeah, so I mean, if nature and evolution have given us the tools, it seems almost like, that's like the gods whose face we're spitting in, by saying, no, we can do this better. You've given us technology, we'll take it from here. So that's just my 2 cents. And I would like to, I think we should, if anything, we should look at maybe listening to the wisdom that comes out from this natural product, because it's pretty legion. We know a lot about how to provide food, clothing, shelter, education, healthcare for everyone on the planet many times over. We aren't doing that because of a political will. That's not a breeding thing. It's a power thing. So that's kind of where I'm going with it. Who do we empower? Who do we say, okay, you're pretty, go sit in the corner and whatever, play with your blocks or something. So that's my philosophical rant. Thank you, Cleveland. Tip your bartenders.
Yeah, no, absolutely. But what you just said reminds me of maybe another really strong caution against using polygenic embryo screening to try to increase intelligence or educational attainment, and this relates to evolution. So evolution is not directed toward any kind of progressive end. It helps, it increases, I guess, the fit between an organism and its environment, right? Evolution selects for more reproduction within a given environment. And the polygenic score for educational attainment represents the genomic variants that are correlated with high educational attainment in our current educational system, right? Which is very unequal. It's very biased by race, by socioeconomic status, by gender. And so what we have found, we haven't found genetic correlates of intelligence, some kind of some kind of absolute idea of intelligence. What we've found are the genetic correlates of success in the educational systems of wealthy countries with white majorities. That's what we found. And so if we use that polygenic score to select people, that's what we're selecting for. We're selecting for people who have succeeded in that environment for whatever reason. We still don't know what the relationship is between these genetic variants and educational attainment. But that is what we'd be selecting for. And I think that's a big caution, is to remember that we can't separate genetics from environment. And so whenever we're doing genetic selection, and this is true for animal breeding as well, you're selecting for a particular trait in a particular environment.
Right. And I love what you said about maybe the best investment of our energy and time is to create a better environment for everyone, and then just let the thing boil. Because I think one of the components one of the factors that would go into success or failure of the development of a species is economic. If you're born into poverty, you might be a genius, but you're going to have an awful hard time being heard because no one wants to hear from the poor kid, no matter how smart you are. And I'm sure that there are stories that people would float out. No, what about so-and-so? The odds statistics say you're less so. And so I think that the wisdom is, as you said, let's double down on creating environments that will facilitate growth. So let me. And I'm just putting words in your mouth. Listen to what you said. You're racist. Let me go back and just say, you as a historian have studied the past of this. You've studied the growth of this technology. You've seen people trying to appropriate it. You've seen people misuse it. You've seen people setting expectations that aren't realistic. You've also seen where we've made gains. You've witnessed the trajectory from inception to present. I'm going to ask you to infer from present on, what does this look like?
What you're asking, what polygenic embryo selection looks like in the future?
Mm-hmm.
Wow. So that's something that we are not trained to do in history PhD programs.
But have you seen a pattern emerge that points in a direction?
Yeah, I have. And what I'll tell you is that I started working on this project in 2019. And since then, the science has increasingly suggested that polygenic embryo selection for educational attainment would not work. Many studies published since 2019 have shown that educational attainment is much more complicated than people thought even 7 years ago, and that the genetics of it are much more complex, much more environmentally contingent, and that it's much less likely that this would work than we thought in 2019, or than anyone thought in 2019. And yet, there are now many more companies either offering this service, kind of making it available behind the scenes, even if it's not listed on their website, and going further to try to figure out how to use DNA editing to edit embryos in addition to just selecting embryos. So we've seen a split just in the past 7 years between the science on the one hand, which really suggests this isn't working the way people thought it would, and the commercial side of things, which is going full steam ahead. And so thinking about that split worries me. I worry about the resources that are being put into polygenic embryo selection, embryo editing, further research in these areas that could be going elsewhere. And I worry about the public perception of intelligence or educational attainment as a genetic trait. So that's the pattern that I've seen and my concerns about it.
Okay, so I'm gonna write a bullet point version of that, and I'm gonna say, as you out there in podcast land, if you see ads come across your Instagram feed promising that you could engineer your kids, don't give them any money. That's the takeaway from this. Not until Emily says it's okay. Is there anything we missed?
I don't think so. This has been such a delightful conversation, even though it's about a very, alarming kind of trend.
Yeah, it's going to take me 2 days to come down from this conversation. I'm going to be like, tomorrow's coffee is going to be like, what? What did we talk about yesterday? Why am I so concerned about the future? But it's great. Thank you so much for your clarity and your vision. It was wonderful to have this conversation with you. And please come back and tell us more.
Thanks, Ed. It's been wonderful talking to you.
Okay, bye-bye. Sincerest thanks to today's guest, Emily Merchant. If you'd like to learn more about Emily's work, check out our YouTube page for links to her bio, books, articles, research, and more. And thank you for joining Minds Over Matters today. You can find us on YouTube, Spotify, and Apple Podcasts. Please subscribe, share with your friends, and spread the word. We have a lot to say, and we guarantee something for everybody. Minds Over Matters is hosted by Ed Kiggins, produced by the College of Letters and Science at UC Davis, and filmed at the Wyatt Pavilion. Thanks for listening. We'll see you again next time.